And you can see, so this is the UI from the actual running on the Python API that I have set up. I'll go ahead and give myself a little bit more space. Works much better on 2 monitors, or 3 or 4. But we only have what we have here. Okay, so what we see here is the simulation. Actually, we have a sonar sensor or a range sensor that's detecting this robot that's running around. So these are all just autonomous robots that we have. I think I have like 10 of them. And so to get that to launch, you have to run the simulation. So you can run the simulation, and what we have over here is I'm going to click on the little button right here. It says gamepad. So I've got one of these gamepads right here, and I can control just like a little game, for lack of a better description. But what's more important is the fact that you see, as I'm driving around in that simulation space, you see all that information on the vehicle state right here. So we see the position in the global reference frame being transmitted from here. So where that robot is sitting is right here. I haven't set any of the commands. This is for the command, the control section. Well, I don't have that set up on this particular version that I'm showing you guys. But this is the position. It shows you the heading of where that robot is, so you can capture all that information. It's going to show the velocity. So watch now, as I'm driving around, I'm getting that information about the end effector, for lack of a better description. So that is what I'm looking at. Also notice down here, so we have these wheel velocities. I can also do positions. It doesn't make a lot of sense to do a position, but I'll show you where you can bring that information back from. But what's important is this is each one of the 4 joints. You guys have 4 joints right here. And so you can see the velocity, you can see what it's being commanded to, and you can see what it's being measured at. So the command really coming from the joystick, from the gamepad, and then the measure is what is being measured in Copelio. So there is a slight lag because it takes a second for the robot to actually come up to speed, even though the joystick is completely down. Also notice that there is that sensor that you see, that camera. So here's that vision sensor that's mounted on here. That's also turned on. So that's actually what we see, these blue lines showing, is that's field of view of that particular image sensor. I don't have that fed back in because that's going to be the next discussion we talk about when we talk about computer vision. I will show you how I will control the hardware in the other code, but since there's no hardware here, it's hard to give you that. Also notice that I've got graphs that are connected to the system in here. These are, I disconnected, actually was doing some other things, so you can ignore that one. But you can see that the graph on that right is sensing the information from Copelio. You can go look at the tree if you want. There's the tree.
Good question.
Yeah.
Are those graphs being generated by Copelio, or are they being generated by Python?
They're being generated in Copelio based on the data.
What about
In fact, that's something I want to talk about.
what about the data?
This data, it's being, you'll see where it's happening. It's receiving the data from the joystick, and it's sending the information with the commanded velocities here to the simulation. All the data here, all the measured, is being measured from Copelio. Okay, so there is that back and forth connectivity, and that's why I wanted to show this one, because this one actually shows it better than the robot arm does. So we can see that kind of stuff.
Professor, but what I mean is like this is like coded in Lua or Python to be displayed.
This is all external Python API.
Oh, okay.
Which is what you'll more than all likely do.
Okay.
All of you will more than likely do it this way. So that's what we're going to walk through. So I want to give an example of what we're doing here, so that when we walk through the code, you understand what's going on. Now, there's some caveats, and these are some of the things I want to talk about. To see this in a nice, how many have written Python code? How many have written Java? If you've written Java code, it's pretty easy to write a GUI, isn't it? How many have written C#? Easy to make a GUI, isn't it?
Yes.
Is it easy to make a GUI in Python? Hell no. You could do PyQt or SciPy, whatever you want to call it. You could use WX Windows. It's not very fun either. I have a GUI. You're like, well, how did you do that GUI, right? So these are some of the categories we'll talk about, because to make those work, you have to give, there's some traits, right? Typically in Python, what do you see? You see something that looks like this. Right here, right? You see this kind of stuff. You see, like for example, if I go to, just so you guys can see this, if I click right here, you can see that, that's just a print, right? And so that's what you're typically used to seeing, is a command prompt interface, which isn't very good. Especially if you want to see this stuff right here, it's updating, what do you see here? It just sits there and scrolls up, right? And that's sometimes really hard to see that little thing, right? And that's where the graph comes in. And then you say, well, I want to see, if you really know Python, so I want to use Matplotlib, right? Except you can't. And that, what's that?
So thank God.
What, you can't use Matplotlib? Actually, it's very powerful. I wish you could. There's a way to make it work, but I'm going to talk about the caveat. So if you notice, when we're looking at the code, this is the baseline code. There's some new code I'm working on with this. This is why the controls is turned off. At the moment, this is only now let me walk you guys through the how I did this. So let's go ahead and quit, and let's go ahead and simulation is not quit. Okay, so let's real quick get the easy part out of the way. Let's look at the simulation real quick. And let me turn on the scene hierarchy. There we go. So what do we have is I've got the Scout vehicle, which is this vehicle right here. And attached to it is the body. This is the joint, the joint, and the joint. And then the prismatic, not the prismatic, the primitive. And then what we see here, the window dressing, as we called it before. What's that?
The mesh body?
Yeah. So these are just what makes it look good, but I use primitives for all of the different elements. I even have the sonars that you have right here, and I have the vision sensor. So when you're using the camera, you're not doing the camera. Remember, when we're talking about camera, we're actually adding this thing called a vision sensor, which we get over here. And we have the vision sensor, and it's a perspective type vision sensor. So that's what you're using for a camera. If you try to add a camera, that just allows you to see the scene differently. But if you want to see what the camera sees, whether it's on the robot or not, I think we showed this, we talked about this already, that's when you would do a, where's that? I'm trying to always remember, I always forget what happens at. We do right click, that's right. Right click add, and then we do a floating view, and then you would add in that floating view, you then click on that, and you want to associate that with one of the cameras that you have here, so that's how you would do that. Okay. It's kind of weird the way they do it. I'm sure there's other ways that are less weird, but it's the best way I know. So this is your robot arm, this is your autonomous vehicle, this is whatever you're simulating. And there are things in here, right? So we know that there is motor aft right, that's the name of it. This is the motor forward right. And so these elements, these are important. We have to know what we're naming these. So this is one of the keys, these are the handles that the simulation uses. If you want to do the graphs, you can add a graph in and you can associate the graph. I can provide this file for you guys, and I think David, you're asking me to send you the IKA file. I thought I already posted it. I'll post it today, or probably not today because today is super booked. Because we have not only all this stuff, all the classes, but we also have a banquet, and so probably not till tomorrow. So, and John, I still forgot to post the Yeah, I'm telling you. It's weird. Tuesdays, it's like, oh, I have a day off, right? But I don't. It is like jam-packed with like things just trying to get caught up. So we're still working on that. So just hold tight. If you haven't written up your analysis, you can still write your analysis up. So just don't sweat it. If you've already done it, it's just as soon as it goes live, you'll get it. I promise. Also, you're not going to get your exams back today. So here's why. Actually, they're almost all graded. But I got a couple students who need to take the exams. They're going to take them on Monday. So I'll probably give them back to you on Monday and kick them out. So that's the plan at least when we go over it. But I didn't want to have a lot of time between just because I have to preserve the integrity of the exam. Even if I kick them out and then did it, I can do it the day of because there's not much turnaround. But I have to preserve the integrity for them and you guys see. So, that's why we're doing that one. So if you don't like it, you can complain to them. I'm just kidding. Okay, so we have all this information right here. So this is from the scene that we're going to actually be talking to. We're going to be talking to where is the scout base at also. Okay, so again, this primitive scene or the elements, the handles from the scene we'll be using in the sim. Okay. To see what the sim code looks like is very irrelevant because it really doesn't do anything. It's just doing this. It's just simply creating these guys. It sets the initial velocity to 0, and it's articulating this guy right here, which we already set to 0 in this case. Okay? So it's not doing anything. The robots right here, though, so if you want to have that scene that's interacting like these robots running around, then we need to run it. So for example, depending on how you configure it, let me go ahead and restart this. And if I'm not mistaken, can't remember if I turned on or off. Let's go to gamepad. And let's go to sim. Yeah. So I automatically started the sim. Okay, I'll show you where the code does that. So when I start the Python code, the simulator is automatically started. So it makes things convenient. You don't have to do that. And in fact, if you're going to be doing this over the 0MK, what we need to do is you come over here to connectivity. What you do is have to get this ZMQ, the 0MQ, has to be running. If that's not running, then Coppelia Sim will not be listening to any command sent to it. But you can make Coppelia Sim listen even if the sim isn't running. There's some switches you can put in the configuration to do that. So I'm just kind of giving you a heads up on that part. Okay? I tend to like it run because what will happen is you can be goofing around with it and then it'll want to say, like if you close it, you'll want to say, it'll say the new position. You're like, no, I want to start from the same spot always. So I found it's easier to do this. I don't get in trouble with that. So let's go ahead and walk through the Python code here. Quick. And then so I have a quick button. So how did I make that GUI, right? That's the first question that you might be asking. So I'm using what's called Pygame. So Pygame is a Python library that does a really good job at allowing you to interface to joysticks, keypads, putting graphics on the screen. I mean, it's a full-on game engine. In fact, it has a game engine in it, which is good and bad. And I'm going to talk to you about the differences on why you can do this. The first thing is, let me just go ahead and start it so you can see that UI. So I actually created buttons that you can interact with in Python. It's actually not that hard. And I'll show you guys the code next. I'll give you guys this Python code so you can see it. I'll give you guys the more stable version of it. It doesn't have the controls and the ROS set up for it. It's just got the gamepad, but you can see what I've done. So notice there's a little bit of flicker, and that's because as these are changing, it's actually overwriting by putting a white background, and then so basically erasing it, and then it's putting this on there, and it's doing what's called blit. So it's blitting the screen. So in the game engine, it has to run in a loop. Okay, so it's got this game loop or this engine loop. That engine loop has to be updated. So it makes all these changes at the very end. You tell it to do its thing, and it does its thing. And it's like if it's playing games, you have all this stuff, and it updates the game. Does all the stuff, updates the same, updates the game. What is it doing when it's doing all that stuff? It's reading the keyboard. It's reading the joystick. It's displaying to the screen. And that's great. And if all you're doing is Pygame with the joystick, it works great. Okay? But we're doing more than that, aren't we? We're actually interacting with another engine. We have another game engine. So we really have two game engines, or two simulation engines, if you want to call them simulation engines. It's the same thing. And that's this one right here. And so we're running the Python engine. As we run through, we're saying, hey, we're done with all of our stuff. Now, whatever we're going to do, we want to tell Coppelia Sim to do its stuff. Don't do it before, because it hasn't gotten good data. So we're going to do all our calculations in Python over here, and then we're going to say, okay, I've sent you a whole bunch of data. Go do your ODE equations through the simulator, the dynamics engines, update your screen. And it'll go through and update all of its stuff. And so this guy up here is how fast that engine's going to run. So if you run it at the delta T over here, we've talked about that before. If you come over here to the simulation, and we talk about the simulation settings that we see right here. So this is how fast the simulation's running. This is our DT. We have a 5 millisecond DT as well. So it's going to go through and do everything in this. Once it gets done with that, guess what? Then it goes back to the Python, and you can do the Python stuff. So you get this ping pong effect going back and forth. And that's not really a bad thing. You're going to see a slightly slow response, but that might be okay. You saw we're driving around. We're going to have a bunch of the robots running around, so it does go a little slower. But it's pretty responsive. You kind of do a whole little arc going on. Now, there's one more caveat. If I want to see graphing data, I can use my graphing data from Coppelia. I cannot run matplotlib directly because it wants its own engine also. So if you try to do matplotlib and Coppelia Sim in the Pygame, it's going to starve the connection on the ZMQ and error out. So if you don't want matplotlib, great, no big deal. If you do want matplotlib, you're not using it. You're not using Coppelia, or you're not going to be using. Actually, you can use Coppelia, but you can't use Pygame. So it's really Pygame that doesn't like it, but Pygame causes the stall with the connection over ZMQ. So you can do Pygame in matplotlib. You can do Pygame and Coppelia, but you can't do all three. The only way you can do it, which I'm debating, do I want to do it, is I could open up another queue. And so if you know anything about threads, I can create another thread, which is in process of a queue, to send off to another basically like a Python, or like a Coppelia, and do my own display information. And I don't know if I want to deal with that, I'll be honest. It doesn't work that I want. So that's kind of where I'm at on the simulation. That's why you saw the control didn't have any of the information on that. It doesn't really have any pertinence to what you guys are doing here, but I wanted to give you guys the caveats. So if you wanted to make a cool GUI that responds to joysticks and keyboards with the screen that we see right here, that's probably the easiest way I know. You can go into PyQt if you want. If you want to do WX, you can do all that also. It's a lot of heavy lifting for a very little game. So command screen might be a good option. Because if you want to read joystick by itself, there are a couple of joystick libraries that don't require Pygame to do that. So Pygame gives you the ability to read the joystick easily. It allows you to display something to the screen as a GUI, and you can even create buttons to respond to with your mouse. Again, I'm just giving you guys the options and giving you this. This is what I've learned in the last 2 years of writing. 2 or 3 years of writing this type of stuff with Coppelia, with Python, with Pygame. Am I a fan of it? No, I'm not. Still 100% sold. There is another way to do it. I'm just going to give you it's not a very good way. If you want to use matplotlib, you can create the matplotlib in the background, convert it into an image, take that image, and then you can dump it onto the canvas of your Pygame. The problem is that process takes a little bit of time, and it slows the entire engine down. Python's not speedy to begin with. So you have the slowness of Python going through doing all this other garbage going on. So if you're trying to do the reason I bring all this up is depending on how if you're doing OpenCV in Python, depending on how you're presenting that using, say, Matplotlib, you may not be able to use Pygame. But you can use Matplotlib in Python with Coppelia. But you lose the joystick unless you run a separate joystick interface. And you won't get all of that. Okay? So you got to pick your poison. So far, so good? So I haven't gone to any of the code. We'll go into the code next. But I wanted to give the caveats of all of this so you can see what it is. And I don't want to over-advertise saying, oh yeah, you can just use joystick and use Pygame and use Matplotlib. No, there are things. And unfortunately, you hear people say, oh, you can just do this and just do this and just do this, and they actually haven't done it. They're just assuming it works. It doesn't always work. Any questions before we start to go into the code in general about any of this? So it's a very powerful tool. I don't want to discourage you guys from doing that. Very powerful. I just want to show you guys. You'll see a lot of code just for the UI so that I don't when I'm updating my numbers, it's updating right here. If I don't do it a certain way, I'm going to show you guys what will happen is this number updates. It'll overwrite the number on top of itself in Pygame. So like that 4 and that 6 on the 86, 87, you'd see a 7 superimposed on the 6 for a moment in time until you saw a 7 again. So you went from a 6 to a 7, it'll overwrite, and then you got a 7 to a 7, it'll stay on there. So it gets kind of funky. So some of that code that you'll see is to minimize and mitigate that. But you also see it flashing a little bit too. Why? Because I have two engines that are toggling back and forth between one another. So that's some of the artifacts of the ping pong between the two engines. And quit will quit. Both of them. All right, so how did I do all that Python stuff? So first of all, I prefer Studio. Yes, I know it's 22. I need to update to 26. It's on my to-do list, but it's working in 22. And sometimes when it's working, you don't want to upgrade and go and break everything, right? So I'm running 22 for Visual Studio. Can you run Visual Code? Yes. I prefer Studio. That's just me. You can run Python in here by setting any version you want. I have it set up for 3.12 for my environment. You can set any number of environments you want for Python. I'm not going to lecture that. There's a lot of good how-tos on how to do that. So that's the first and foremost. So you pick your Python coding, poison, pill, whatever you choose. Is anybody using Studio with Python, or is everyone using Visual Studio Code?
Studio Code.
So is anybody even using just pure Visual Studio for Python? Anybody know you could? My preference, I prefer Real IDE. All right, let's get a second. So you can see I'm showing you guys the baseline code base we're looking at because that's what's working, and obviously this is the one that I'm currently developing, so I'm not going to show you that because it's got a bunch of errors and bugs. It's not bugs, but it'll show the problems. Okay, so you import all your NumPy, SciPy, decimal, and math you want to do whatever you need to do. I did try actually using Plotly. I don't recommend it. I have created threads and threading queues for these as well. This is what we do for that. So do threading and do the queues. If you want to do additional queues to send data out, to do whatever you want to do. It's not necessary though. So this is for when you are threading. Has anybody written threaded code for Python before? It's like you can have multiple threads and processes running concurrently. Here's the caveat if you do that in Python. So I've done a lot of Python code. It's not a true thread. Let me say that. In threading and multi-processes, you have them like running concurrently. You get the virtualization of concurrency. In Python, you have this called global interlock, or this GIL, which isn't really a true thread. It means you can live in your own little space, but you're only executing one at a time, and this global interlock prevents things from actually being purely concurrent. Other threaded processes with the OS, you can run them concurrently. Python is not true threaded. It's just FYI. So if you didn't know that, just give me a heads up on that. But you can do the threading module or approach. All right. So Pygame is where I'm importing Pygame here. This gives me access to the joystick, the keyboard reading, and the screen displays. If you don't want to use Pygame, don't import it. You also have to import this guy right here. This is what allows us to talk to Coppelia Sim. I am talking using the new interface using the ZMQ. There is an older API they support still when that's talking over UDP on the local port. Now, believe it or not, this doesn't necessarily have to run on the same computer. If the computers are on the network, you can run it on 2 different processors. Very, very powerful. Same thing on the old networking approach, where you set a port and a port command. You can set the IP and the port to what you're talking to, and you can set that here. Okay. This is how Coppelia Sim is actually recommending to be done. Yeah.
Will we have to open that port in the firewall, or should
it depends on how your computer's set up. Sometimes you do. I've never had to. ZMQ does not require it. So I did not open anything on my firewall locally to do this. Between 2 computers, maybe. Depends on how you have your firewall set up. So your mileage may vary. Yeah. But good question. OS imports, those are all kind of stock standards that I have here. PyDoc, this guy right here is just kind of, you just kind of copy and paste stuff in when you get to the point of it. So you can run different OSs. So that's just no big deal. The other thing that I have here is we want the joystick to work in the background. So we set this OS environmental flag on there, and we set it to true, so that we can run the background events. So that's a very powerful thing to do. Otherwise, it can cause the game loop to really slow down. So that's a very important step. All right. I'm going to go through this kind of quickly because this is more for the Pygame UI creation. But there's this little function that's right here, which allows you to kind of like put words on the screen, and it changes the background and does some cool things and whatnot. So you can go down the rabbit hole of Pygame, but this thing called Blip is essentially to update the screen display, is essentially what's going on here. So it gets into creating these surfaces and these canvases, that kind of fun stuff. It's drawing buttons on the screen. So if you've ever done XML for games, or if you did anybody uses C#, actually I'm trying to remember the DSL. What's that? So you've done HTML, right? People who've done HTML. So there's a new version, like you can actually, in modern C#, if you don't do the old school, like the old Windows version, where you have the DSL running that describes the markup, and then you talk to that kind of approach. Has anybody done GUIs like that before? Am I talking to somebody who's never done it? It's like all free to you. Basically, this is like that way of doing it, where you're defining the objects, for lack of a better description, that's going to provide you that button behavior. That's all we're doing. So we're creating these little rectangles that we're going to have a certain radius and blah, blah, or a certain shape and whatnot. And then after you get done drawing these things, we need to put them on the surface. And we're going to put various text on the surface. We have to define what text is going to be. Again, I don't want to go into a Pygame tutorial, but there's a lot of Pygame in here, so I just want to show you where the Pygame stuff is at. I have to erase the text. So when that text is updated, I need to erase it first, so that I can write to the screen without them overlapping one another. This white rectangle is where I have text. I have squares that I'm writing as I basically erase the text, and then I can then put the new text on there. So when you saw that white kind of blinking, what you saw was a white rectangle being drawn over the old text so that I can put the new text on. Make sense? Again, it's part of the Pygame GUI. Here's where I'm drawing the text, and you can see all the text that's being done. So if you've done GUIs before, this is kind of like modern way of doing GUIs. So old school, VB, original C#, Windows versions. This is not like that, but the newer versions, you have to do something more like this. And then here is, again, more, this is setting particular variables, or this is setting the labels for the variables to be shown. So this is all, again, Pygrames, this is all just drawing the text. So I just create a function to draw the text on the screen. And this right here is simply updating that text on the screen. Okay, so I'm just setting the values to their locations, and again, this is pretty obvious. You could probably walk through this and see this, but this is all Pygame. When you get done putting anything on the screen, you have to do what's called a display flip. Basically, it says update the screen. So when you get done with that function, last thing you do is you put all the stuff into the buffer, and this basically takes the data from the buffer, puts it on the screen. Okay. So again, it's all Pygame stuff. This isn't doing anything, so I just got to pass on that. Okay, so that's all the stuff for the UI. This is really where we start talking about the configuration. So if I'm running Pygame, I'm going to set it to a clock. So I set clock. I get the value of the clock. I'm going to initialize Pygame. So that's what's going on here. Here I'm going to initialize the display, the joystick. And so this is going to read the joystick. It's going to come up and tell me I have joysticks. And it's going to tell me how many joysticks I have, right, with this command right here. Then I'm defining the 0 one to simply be called gamepad, and then I'm going to initialize gamepad. It seems kind of wonky. You just got to go with it.
So you define how many joysticks, right? And then
There might be more than one on there, yeah.
so you tell which one you want to use.
Yeah, because you can have like 4 joysticks. You can have a bunch of them on your USB. So I'm just telling it which one to take. Take the first one that I have here. I only use one. And then you can see all the different features of there if you want to print it out. So here's a little print button. You can do a 4 in range on your Python code there. Okay, so this is setting up the joystick. After we've imported the Coppelia sim, we've imported Pygame. So if you're using Pygame, you have to do that. If you're using joysticks from Pygame, you need to use that. If you're going to use keys, like just key presses, Pygame will support the key press on the keyboard. So if you just want to do like A, B, C, D and control, that's like the other sim that you've seen before, it's doing it's the key response. Once you've done that, now we have to do what's called, we need to create a client through the remote API. This is the line that allows us to talk to the client to Coppelia Sim. So we need to do that, get that API remote. Then what we're going to do is assign sim, is we're going to get the client, so this API object that we've now instantiated, we've defined it here as this method of getObjectSim, define that to sim. So now we have a reference to that sim object. So you got to do this, and then you have to do this. And you can do a little bit stuff right here, if sim, so in other words, if it connected, you can say connected to Coppelia Sim. Apple Pie and another version to actually know you connected to it. The next thing you need to do is tell Coppelia Sim that you're going to do stepping. In other words, the Python code is going to control the stepping of Coppelia. So that's how they start to be lockstep. So the code is going to, Python code is going to step, it's going to tell Coppelia when you're going to step. And we're telling it that we're going to use the external API to step the simulation. And then I start the simulation. So I don't have to hit the go button on the simulation. I can do sim start simulation right here. Convenient. You don't have to do that, but it makes life convenient. So if you have a bunch of stuff going on in the background that you want running, might as well start it here. Anything you do in Lua or in Python inside Coppelia, you can do right here. You have to do sim dot because we're doing this sim dot. You can call this Bob if you want, and then you do Bob dot, but that kind of doesn't make any sense. Okay, so sim dot, okay. Right here, I'm setting the position of the vehicle that's going to start right here. So this is just my tuple that I've set, okay? So that I know where it's at. This is stuff just for the GUI, so I'm just setting some offsets as constants. It's the easiest way to do it. So I can move things around without having to go into the code, since you saw it defined through a function. These are labels for the buttons that you see right there. You're not going to be doing queues, but if you do a queue, this is how you start a queue. So then what I did is I created, can you see the text in the back? I know it's small text, but I don't think it lets me change font size on the fly.
You can't just like control scroll.
Let's see if we do control scroll. Yeah, okay, control scroll.
Can you do a little more?
Sure. Now that you can see it. Is that better? So these are all just the commands. These are just all the variables that I have. You can see how I've written them. Your style of Python is going to vary. This isn't a Python coding class. This is how I usually write my Python. This is how I normally write my code. Again, your mileage will vary. I'm not going to grade your Python code. Professor Powers, he will do that for you instead when he teaches Python next fall. If you're not taking it or you've already had him with it, then you understand what I'm going with. But he's a good instructor. So I'm setting up my variables. Now, what I have to do next is I've initialized all my variables and declared them. Now what I'm going to do is those handles in the sim, I have to define my handles here as well. So this is key. I like to make my life easy. Lowercase, I mean, again, how you do your variable nomenclature is up to you. Underscore is also used sometimes, but I will tend to lowercase up front. Again, do whatever you want. But left aft, I always flip them on purpose so I don't accidentally get them messed up. That's just the way I do it. But this is left aft, so this is each one of the joints that I have right here that I'm doing this, getting the handle of the joints in my sim. So I have sim dot, I have to do get object. That's the key command in the API that does that for you. And then you have to do the dot forward. So this is the hierarchy. This is the same hierarchy as a tree structure that you have to put in there. I also have the scout, which is the base of the vehicle that I use on there as the overall objective. If you're doing the tip, say for example, the end effector, maybe you're going to do that instead. You want to know where your end effector is at. But that's like if you want to set the destination with an inverse kinematics, for example, then you could actually use this instead. I have not done inverse kinematics yet. I was going to set that up in the next day or so to do it. The vehicles don't require inverse kinematics. So that's why I don't have that set up here. You can do inverse kinematics through the external Python, because anything you do in one, you can do in the other. Anything you can do inside the sim, you can do external to the sim. Okay, so it shouldn't matter. I just didn't get that example worked out for you guys yet. Just setting define the controller mode, so that's just really for accounting purposes. And what I also did here was I just did a scale factor. So this is how much faster you see the thing going in the sim world versus the real world. Next thing you want to do, if you're running Pygame, typically we do this thing called run. So this is run variable. We're going to set as a boolean to true. And it's just for a while statement, but it makes the code easier to read. Here's just the Pygame. When you mouse over something, it changes whatever, detects it. So this is just, again, the square for the buttons in the UI. So you can read that if you want. I'm going to skip that. If you don't have to use buttons. It just made it life easy. I was playing around with it. Again, anything you do to the screen, you draw. This is me calling the commands to draw text, and then you do a flip, update the screen. All right, so you saw the while one. This is basically the while run. So run is set to true. So this is that while statement. So this is doing that loop, that event loop for Pygame. Okay. So this is the screen buffer. And then what we're doing is in Pygame, this is where you can detect the key presses. So if I pressed H, you would have actually seen on the command prompt, hello showing up. So if you want to do key press to control your arm, like 1, 2, 3, 4, 5, then you can do the key presses right here. Maybe if you want to do joint 1 forward, joint 2 forward, joint 3, joint 4, instead of using a joystick, you can do that, and then you can go below to, QW, ERTY, so QWERTY, if you want to do 1, 2, 3, 5 forward, QWERTY is 1, 2, 3, 4, 5 reverse. You can hold the R button down and toggle the reverse and the forward mode if you want to. It's really up to you guys. So you don't have to use a joystick, but this makes it really easy to control the key or the robot joints from the keyboard also. Everybody with me so far on that? So I'm detecting this event called Pi event. So here's Pi game event. I'm going to detect this. Then what I do is, if that stop button was pressed, then run false, run to set the false, which fails this while loop, and we're done. If it's not false, then basically I'm going to run the next set of inner calls or inner events. So now what I'm going to do is I'm going to check my mouse and see if I have a mouse. So this is where I'm detecting a collision between the rectangle for my button. So this is basically button detect, for lack of a better description. Then I'm checking the joystick. So I'm going to read the joystick. And when you read the joystick, there's a lot of different ways you can read the joystick. You can read the gamepad axis. So this is going to be these guys right here, the analogs. You can also read the buttons. And so you have the buttons that we have right here. You could do the event hats, and you can detect the buttons. But it doesn't really matter for the arms. I'll show you the code for the other robot arm that I have, and you can see there's a similarity to it. But in that case, I'm not necessarily using the analogs at the moment. I'm using the buttons down here, the keypads, the game pads. So that's what we're doing for that. So I'm reading the joystick value. And then I created my own modes. So this tells me which mode I'm in. So this is, if mode is equal to joy, then I'm going to simply set the velocity forward, aft, left, and right to whatever value I had on my axis times the simulation scale factor, which I set to 8. Okay. This is the scale factor. I'm going to pass on this. And you guys know about the pass command in Python? It means just skip it. So like right here, I can stub out the code, and I can put a pass underneath it and it'll ignore it. If you don't know that, powerful. If you know it, great. Okay, so here's what I'm doing right here is I'm setting my command velocity. I'm just rounding it and to 4 decimal points. Otherwise, it can get really, really long. So I'm just rounding that value off so I can display the information on the screen. So that's really what's going on with that part. And that's it. So that's the commanded values. Now, to see what the data is in the simulator, I'm going to set this variable velocity left forward sensed. So this is the sensing from the sim. This is not what the joystick is telling me. This is what the simulation is telling me. So if I was going to go up a really steep hill and I couldn't go that full speed, it won't match. So I'm going to get joint velocity and then I use the handle. So if you want to get the velocity, if you want to get the position of a joint in your Python, you can do sim.get joint position, joint 0. That's going to give you the position in radians per second or in radians. Coppelia sim uses radians. So that's why if we haven't realized that, it's using radians or radians per second for velocity. So here we have getting all four of these. If you got 6 joints, you can obviously do 6 of them. It's no big deal. Then right here, I'm getting the state and vehicle data. So this is telling me where the scout, that's the base of the robot's at. So if I was doing it on my robot, that might be my universal coordinate system of where my tip is in the U frame. So where is that in the U frame? Right here. This isn't, so I'm getting that information, that position, I'm getting that object, that tip. So I could put a dummy on that tip or a little object on that tip if I wanted to measure the dummy itself. You know exactly where the tip is instead of having the center of mass or the center of the object. Maybe I want to have a dummy. The dummy you can put right at the tip in the physical domain of the arm and get that position. Or wherever you wanted to measure that position, I could use a dummy instead. And when I would do the dummy, I would name the dummy something, not just call it dummy, and I would read that dummy when I did the handles, right? The SimGet object. So here I'm getting the position, I'm getting the heading, I'm getting the velocity, and I'm getting the pose. We've talked about that already. So I'm getting all the information. Again, this is the quaternion. Okay, we talked about quaternions. And so we have all that information. And you can, obviously, you can print stuff out. If you want to just print it to the command prompt, that's fine. This is obviously the easiest way to do it. Let's see. So here's if you want to convert, you can convert. This is the conversion that goes on inside of it. So that's how you get to the information from here. So I got my x and my y value. I take the values that I have right here to get to this guy right here. So here's my sine, and here's my cosine, and this is how we do that. We've talked about quaternions. That should look familiar. Except instead of having all the variables, we actually have the values returned from the tuple in the pose information. But again, pose is a quaternion. Okay. So that's my y value, and this is my x value. And I can find my heading out by doing that. So I kind of made life a little easier. So here's my a tan 2 that I have for my heading. So again, everything we talked about in class, it's right here. So did we use it? Yeah, we really do. You could ask for the matrix, and then you can decompose the matrix if you wanted to, but it's your choice. Do I get my linear velocity? Again, it's returning, in this case, the velocity of scouts giving you a tuple, so x and y. And so that was what we see right here. And I know I could have done the other ones, but it is what it is. So linear is this tuple, and then the we take this guy right here to get the angle. So 0, 1, 2 for our heading, x dot, y dot. Any questions so far? This gets a little, I don't say wonky, but you kind of have to dig a little bit to see this data. So you have velocity scout. Remember we read velocity scout right here? So here's Vel Scout. It's getting this object scout. So we have to like take that apart is what we're doing here. Here's Vel Scout, and this is Vel Scout. And then I got to take this guy and I separate him out further. Do you see what I've done? So you have to separate them out. What's up? Yeah, so that's compounded of compounds. It's like a tuple and a tuple, or it's a nested tuple. So that's what's going on. When I got the sim data right, or the scout data right here, Vel Scout, I got a bunch of information. So I got the XY as its own object, its own tuple, which I decomposed further here in linear. And I have here angular. So 0 is going to be my XY. That's got an X and a Y in it. I've got the angular as the second component. So I created that here. And this was, so the reason I did 2 is it's about X, about Y, about Z. This is angular rotation about Z. Or angular velocity, this is theta dot, or heading dot, for lack of a better description, is in the third position. So I have to get the positional elements. I don't care about X, I don't care about Y, I only care about Z on a vehicle. So if you want to have the about X be about Y, then you do the 1 and the 0 on the 1. Okay. So if we think about like the Jacobian, and we're talking about things, if we think about our D vector, right? So we're talking about this, so our D is X dot, Y dot, Z dot. We're using about X, about Y, about Z, right? This is the angular, and this is the position, or the linear. And then I'm getting the 0, this is the 1, and this is my 2. I don't want 1, I don't want 2, because there's 0, this is the one we want. 0, 1, 2. We don't care about this, and we don't care about this, about this. So that's how I got to the position. But we could actually compose that D matrix, or that D vector, in Coppelia. So we could do the D. So this is the tip, for example, of what's going on. There. And then what we have right here, I'm just displaying the values, so I rounded them off. I took the raw data, and I simply just displayed them with the rounded values, the 4 positions, converted to degrees. So we had these in degrees instead of in radians, because we think generally more in, I mean, how many of you guys think in radians off the top of your head? We're comfortable with degrees, aren't we? So, yeah, that's kind of why we have that here. So that's what's going on with this guy here. This is measuring the velocity, so this is just the square of the square root of the square. So this is converting it into the magnitude that we have, and then this is the measured heading as well. And these control algorithms aren't done, or they're not implemented in this code base right here, because I kept it simple for you guys. And then what we're done, so this comes to, okay, we've done all that for displaying, we've read everything. This is where we're actually setting the target velocity of this. So we're setting our sim. So the idea is if I had some controls going on in here, I can update the controls and set the target velocities if I want to set the target velocities. If I'm not doing it via the joystick. But since I'm reading it from the joystick, I'm just setting the joystick commands. So this is where that joystick is telling it where to go. I'm not reading any of the display information you saw is not coming from the joystick. It's read from the simulation. And that's the point I want to bring up to you guys. So you can do all that Python stuff without having that interface to the real world, to the interface that you have in PySerial, for example, and send it off to the simulation, and you can compare to see what's going on between the two. Next thing to do here, this is really telling, this is me, so people would look at this again. If I'm running at 0.05 or 50 milliseconds, I'm running at 20 hertz. So basically, the Newton ODE is going to this is throttling Pygame. I can't get a return step until it's done. So when Coppelia is doing something, we're almost in a block right here. We're blocking our code. Then we get the response. Then we're done, and now we're going to come back over here. And so our sim step is telling Coppelia, go to your next step. If you want to put a sleep, you can. And you don't need to do it because it's being throttled by Coppelia. And sometimes in Pygame, if you want to put a sleep down there, you don't have to do that because it's already being done in this capacity. Update my displays, and because I'm in that inner loop, I'm done with my while, go back and check on run. If I'm no longer running, set false, quit. Okay. When I go to quit, I'm going to go ahead and tell Coppelia stop simulation. So these are just some nice simulation handling commands, so you don't have to worry about having these two things running independently. Oh, did I start it or did I stop it? It makes life a little easier for you to manage that. And then, of course, we have the obligatory exit. Okay. So that's how Pygame, or I should say Pygame, but the remote API can work with it, including using a UI that you may have developed in Pygame to read the joystick and or keyboard. So that responds on all of this. Does that make sense? I'm going to show you the code for the ARM as well, because it does have PySerial set up in that as well. You can see how that is. I just don't have the ARM, like I said, some pieces. I might have even burned out the motor. I don't know. I'm hoping not. But it wasn't my fault. Really, it wasn't my fault. It was a way. If you're using Robotis and they say to daisy chain, don't. Because what happened is I was updating the firmware on one of them, and I think because of daisy chains, they dropped the voltage too low, and they have bricked the motor because it was chained through their stuff and it stopped responding. Yeah, I'm not happy about that. That's why I said I'm probably by next year I'm going to have my own ARM. that I built from scratch, not the Robotis one. Those are kind of Navigate now. Navigate the Go stuff just yet. So we'll see. All right. Does this make sense on how Pygame or how Python external talks to the simulation?
Question?
Yes, sir.
Can you go to Papelia Sim?
Yeah.
Every time we open Papelia Sim, are we gonna have to go to modules, connectivity, and open that ZQM?
No. When you open your sim, it'll retain that setting.
Connectivity.
Yeah. So that's always running. If you save your sim with it running, it opens it with it running. Yeah, recommend you do that for sure. We'll talk next about how to do the vision sensor and how to pass that information. I may actually have me do the computer vision in Python, or not Python, but maybe use it in MATLAB just to show how you can do MATLAB computer vision, talking to this guy here, to kind of just show the differences. So you can run MATLAB and external Python and Copelia Sim all at once. It will be slow, so I wouldn't recommend having all these little drone robots running around. But yeah. Any questions in so far on this?
You mentioned earlier, like, we cannot use OpenCV and Python.
No, you can use OpenCV, you can't use Matplotlib with Pygame. Yeah, so what's happening is Pygame wants to update the screen, Matplotlib wants to update the screen, and they clash. That's the problem. And it's a known problem. And there are some workarounds, but they're not very clean and they're slow. That's why I actually had the other queues, because I was just thinking about writing a queue to send the data off to its own function. But then I have to declare all of that marshalling of data. I don't know if I really want to do that. So, yeah. Other questions? Okay, let's look at the recent projects. So this is the one that you guys saw the arm. I think I showed you guys already a couple of weeks ago when we started. And then, like I said before, I had to take it apart because there was challenges. Import, you're going to see a lot of similarities. So here's my Pygame, my time, import serial. So the Dynamixel SDK uses its own import. This is what you guys are kind of running on your own. And so this is, you don't really need that. This is just if you're using the Robotis. And again, this is what you saw before. This was the old way of doing it. This is the new way of doing the 0 and the 2. Copelia has changed it like 3 or 4 times. I think they finally settled on this newest version of 0 and Q. So let's see where we're at on that. For your Python, for your PySerial, you have to set your baud rates. For the Dynamixel, we have to set the protocols. And then this is a bunch of Dynamixel parameters. Here's the ARM values. These are the starting points. In the Dynamixels, you don't really care about that, but that might be necessary for you guys to know. Let's see what else. These are some conversion factors. And these are the home locations. So those might be useful for you guys because where your arm is in the physical world may not be where it is in the sim world. So you may need to do the offsets, and this is a way of providing that offset in there. Okay. You're going to have some scaling of what does it mean in the simulation motion versus what does it mean in the real world. So you're going to want to have this kind of sim scale, the simulation scale, or this scale factor set up. And it's obviously going to go degrees. Then I got the times 10 in there. And then this is going to convert from, this is going to convert to the degrees that we have. So this is robot units to radians, for lack of a better description. Each robot's going to have its own robot unit. In this case, in my case, it's 087892 times 10. So I put an extra scale factor of 10 in there on purpose, so I can have some adjustment if I needed it. So I had these two values. And I can make that into a constant if I want to make that into a constant in this guy as well. So that was nice. Then this is internal stuff. And here's my joystick in it. And this is just for these displays we talked about already. Here's the remote API turned on, sim stepping true. And here I'm setting the get object for the handles for joint 1 through joint 6, just like we did before. And so then what I'm doing is I'm moving it to a position of known location. So I'm basically zeroing the simulation. If it's not in the spot where I expect it, I'm telling it to go to a home position in simulation that matches the startup position of the physical world, so that I can get the two to agree. So I need to make sure they're both in that same, they both know where 0, 0, 0 to their reset position. And it was a question you guys had on your exam. Then there's some offsetting going on in there as well. And this guy here is more for the robotics stuff going on in here. All the same thing in here. So this is all robotics where it's setting the different modes of the controller. And more strings that you saw before for Pygame. So here's the Pygame right here. There's this thing called bump if you need to make sure it's updating. Generally, you don't need to do it. Displaying the screens. So this is where you can see more of the keyboard handlers. So again, for Pygame, for keyboards, we're going to do a Pygame dot. We can detect the key down and the key up. So you can hold it down, or you can check for the release if you want. Most times it's just a down, but if you want to do a down and an up, to do different things, you can. And that's just kind of nice. So you do a key down and then the key event. And then the .ki simply means that this is going to be I. So we're listening for the I to be pressed, or the keyboard I. And so what I did that became what was called IK mode. So you have all Python doesn't have a case statement, which is annoying, if you ask me. So you have to do these sequenced if statements. It's stupid, but it is what it is. So you're checking for Q, E, J, K, and all these kind of things. So these are different modes of that. So if you wanted to control your robot with the key presses, this is an easy way to do it. So as you hold down the key press, you can continue to increment by some delta position or some delta theta as it's going to iterate through that range. So a whole bunch of those guys. And then here we are, let's see, this is IK, there's like some sub-modes in there. I'm not going to go into that. Then if you want to do the joysticks, you're actually looking for the buttons instead of the analog mode like you saw before. And this is where you see the event button on the joystick. So you're going to check for a Pygame joystick button down. That's the event. And then you can check if it was released. So in other words, this was I was just pressing it to make it move. Instead of holding it down, it would be pressing. So I was doing the down and then going to the up button, setting value as a toggle to do that. And in the process of doing that, depending on which it was then going to increment or decrement the position of the robot itself, some delta theta. Make them small. If you want to be pressing it like that, or if you want to hold it down, you can just go, you make it so small it's going to be smooth. But that's one way to do it. You can also just set the command voltage to the motor if you want to do that as well. So that's what we've been talking about that one as well, like we saw in the vehicle. So that's a lot of what this part is here. And then what we see here is we're getting a position, same way we saw it before. So this is actually getting a position from the sim. And I can compare the position from the sim to the position in the real world, because I know what the real world is, because I can read that potentiometer. I know exactly what the potentiometer is telling me it is. So all that Python code can manage both sides of that thing. If I want to have the one reflect the real world, make sure it's reflecting it, and I can have that reflection of the sim to the real world by doing that and comparing the two and moving them to where they need to go. This is just a bunch of display information for the UI, as well as this is setting different modes for the joints. That IK is really, in this case, what I was doing was letting Copilot Sim solve the IK by moving the position of each arm to where I wanted it to go, and then it would move to where it needed to do its thing. So pretty straightforward on that. And then this guy right here is basically moving the positions where it needs to go to. So moving to the new position that I have. So I'm updating the physical robot, and then I'm updating the virtual robot, or the sim, or the digital twin is the new buzzword. But that's it. Update the display, and we call it the day. So it's pretty straightforward, pretty much the same thing. In this case, I did the step in the beginning, whereas in the last one you saw the step at the end. I think the step at the end actually does better, playing with both of them already. But yeah, so that's how we do the external API to Coppelia and how you can have it talk to the real world robots, okay, which is definitely something I recommend you guys do. If you want to have it solve the IK, we'll be talking about IK. I guess there's a problem, so we can go through the IK on Monday in lecture. If you guys want to do that, I'll post that again. I think you guys are all now starting to play with it a little bit more, so we'll get that involved. And I'm going to have you guys do an assignment, simulation assignment coming up pretty soon. I also know I did not do the homework questions for Jacobian, so we'll do homework for Jacobian as well. Any questions about external Python? Does it make sense? Straightforward?
No, it makes sense.
Okay. It gets straightforward as you start doing it. If it were easy, it wouldn't be a 4,000 level class. Right? If it were easy, then everybody would do it. But it's not easy. It takes work. But is it impossible? No. Do you have to play with it? Yeah. Is it going to be turn it on, code it, make it work the first time? Probably not. Nothing's ever that easy. So. But it gets pretty straightforward as you start working. Any other questions? All right, so what you guys are doing today, if you have a demo for the electrical, you're going to show me. If not, you should be showing me the electrical working by next Wednesday. Next Wednesday, do we need a lecture next Wednesday, or do you want to wait the following Wednesday for the computer vision?
Well, let's say the sooner the better.
Okay, we'll do computer vision, then we'll do ROS last. Is anybody doing ROS? Yeah, I didn't think so. So let's run computer vision first. That way, since no one's using ROS for this, it's not, to be quite honest with you, ROS isn't necessary. It really isn't. Oh, by the way, there is an IK engine for robotics, for robot arms in Python that you can use, and in part that's part of Pygame. You don't even do Coppelia Sim if you don't want to. If you want to run an IK engine in pure Python. FYI, I don't have it set up. I was looking at it. It looks pretty straightforward. So just throwing that out there. You don't have to use Coppelia for your IK. But it is very powerful. I've entertained the idea of just using that also instead of using Coppelia. I haven't decided yet. But since my Robotis is still not working because of Robotis we're playing Robotis, we're going to figure that out. All right, so next Wednesday we'll go over computer vision, start a discussion on that. But we will use Coppelia Sim to do that as well. So I'll show how Coppelia Sim can be using the computer vision to do that, to send that information over. If I get the robot working by then we'll have the robot working with the camera on that arm. Okay. Let's see. I need to talk with the leads. So we have TBDs we need to refine. So what I'm going to suggest we do is I'm going to take a quick break, turn everything off. If I can have the leads meet up here at this front table, Maria,
Yeah, I remember.
and then the rest of you guys get to work. We'll work till 11. And if you have stuff to demo, I definitely want to see it.